Okay, so thanks for joining tonight. As I said, I'm going to record this, so if you miss anything, I'll post it under the week 10 materials and you can find it there. So I just wanted to take a few minutes to go over the format of the exam and what you can expect, time and whatnot, and the topics. And if you have a question while I'm talking, feel free to interject. Don't feel that you have to wait to the end. And then I'll take a few questions afterwards. I'd like to wrap it up by no later than 8, maybe 7:45. We'll see how much. And then this will hopefully give you all the information that you need so that when you can study over the break and figure out what you need to know if you don't already know it. So let's go ahead and talk about. So I'm going to go ahead and switch cameras so you'll see. I'll write it down as I talk. Here we go. Let me know if I start writing off the paper. I have a habit of doing that. All right. So there's part 1. Now, with part 1, that will take place asynchronous. So there'll be a window of time. So it'll take it. So it's you have 1 hour on Monday. And of course, that's not this Monday, or no, it's a week from today. I'm sorry. Yes, of course. So you have 1 hour, and the time it'll be open and closed has still not been determined, but most likely it'll be early in the morning until late at night. There also will be a period of time where there'll be a window with instructors. So it may not be myself. We're going to trade off the different instructors. So that way, if you're doing it and you have a question, you can just pop in and ask a question. We'll have a Zoom room available for everyone who needs to. I mean, it'll be one single Zoom room, which I'll post, of course. So the idea of that 1 hour one is, again, do. I'm sorry, was that a question? Okay, I thought I heard someone else something. You have an hour to do that part. It's timed, and so the format of it is multiple choice, true, false. Okay, so this first part is MC or true, false. Now, what kind of questions would we ask you on that type of a problem? So, for example, you might have to find attention. So maybe we'll give you coordinates, we'll give you force, you find the tension. That's stuff back from chapter 2, pretty stable or pretty basic. Identify FBD. So there's going to be a lot of FBD stuff on both part 1 and part 2. So what I mean by identify FBD is we'll give you a situation and you'll have, say, tensions or moments, and you'll need to draw the correct free body diagram. Not draw it, but you'll need to select from 4 different FBDs. And so I would say it sounds really easy. Just be very careful to look at the type of reaction. So because remember that some reactions can support moments and some can't. And so you want to be sure you understand that. I would recommend reviewing the reaction types and also possibly having them available to you during the test so that you can look at them, either bookmark them on a page or just so that you have them, because you don't want to make a silly mistake on that part. So, and then another example would be identifying moments. So what do I mean by that is we might give you a diagram, and the diagram might have a vector coming off it at a certain angle. And then you say, well, what direction is the moment about the z-axis? Is it positive? Is it negative? Or you can't tell. So these types of questions are kind of testing your knowledge of how you apply the material. There'll probably be a few calculations in it, but they'll be limited because, again, you have an hour. And the downside with this part 1 is there's no partial credit. So you either get it right or you don't. And that's how it'll be graded. Also, you may have trusses. And so within trusses, you may need to find a value for a member. You may need to
down the paper.
Oh, sorry. Thank you. You may need to find a zero force member. And so those are the two. You might need to find a reaction. And so, and in that, you won't be told which method to use, but probably need to use intuition in that sense. Is if it's a member that's in the middle, you may need to use method of sections, or you may need to use if it's at the edge, use method of joints. So just kind of use your judgment on that. You may need to find a now within FBDs. Remember we talked about FBDs in terms of frames and machines, and what I mean by that is, if you have a frame and a machine, remember how we would take them apart. So you may recall on the exam, the midterm, we had one that looked like it had two pieces to it. It had this piece and that piece, and then they were connected here. And so if you were to take that apart, what you would do, of course, is you would identify the forces like that. And then you'd want to make sure on the other one that this force, that force, and that force were opposite. So that's that kind of intuition you want to understand, is that when you take two pieces that are at a common joint and you put them back together again, you have to make sure these forces are opposite. So, but also within a frame and a machine, you may need to select the correct FBD. So for example, if you had something maybe like the one we did, kind of like this. It was an A, and you had a force here, and you had a force there, a force there. And so you may be asked to draw, for example, what does that leg look like? And so if you were to draw that leg, of course, you would want to recognize that it has a reaction here, reaction there. It also has a reaction here and a reaction there. Sorry, it's getting a little messy. But you'd want to recognize, primarily the important part would be to recognize that this is a two-force member. So you wouldn't draw it like this. That wouldn't be right. You would just draw it with a single force going one way. So realistically, you would redraw it like this, and you'd have, and then. Now, when you're doing something like this, don't worry about the arrows. For example, you don't know which direction these forces are in. You can kind of surmise, obviously, if this one's up, that one has to be down. But again, FBDs are mainly, the purpose of them is to identify forces and moments that are present, not necessarily the sense. So don't obsess over that too much. But if you can get it correct, you will. But so just it's just important to not end up, for example, like identifying this as a non-two force member, because it is. Okay. So basics of friction. So I've said this to a few of you, and I'll just make it known that we won't cover wedges and we won't cover belt friction on the final. So those were lectures, friction part 3 and friction part 4, the last two lectures of the quarter. Those will not be on the final. So what you will have is the basics of friction, which is just understanding the if things are impending motion, what's going to happen? Are they going to slide? And if they do slide, what is the force required to move them and whatnot? So I would say is, if you're studying friction, I would look over the homework, the problems that I assigned that don't deal with belt friction and don't deal with wedges. And those are the ones I focus on, as well as the examples I gave. And then the last idea I want to, and we didn't really talk about a whole lot in class, but the idea of indeterminate and determinate. So the idea with that is, let's say, for example, if I gave you a structure, just a simple truss, and let's say it had a this and this, and so maybe it had a load here and a load there. So you notice that on the trusses that typically one of these will have rollers on one side, and this one has basically an up and a two forces there, and this one will just have a up force. Now, if I drew this such that that wasn't there and it had those, then this would be said to be indeterminate. So if you see something like this, and it doesn't have to be a truss, it could be, another structure. And what indeterminate means is there's fewer equations than there are unknowns. So in 2D, you only have three equations here: some of the forces in the x and the y, and some of the moments. So if you have four unknowns like this, then sorry about that, then you can't solve it. That's why. Okay, so that's part one. So again, it sounds like a lot, but some of these questions will go fairly quickly. You just need to look at them. But I would, don't rush through it, maximize the time, use all 60 minutes. It'll be well worth it.
I had a real quick question.
Yeah, sure.
So, can we also use that one equation you gave us in the lecture, m equals 2n minus 3, to determine whether something is determinate?
Yeah, you can.
Okay, thank you.
Yes, you can. You can use that. You just, it's just that you may have a situation, if you have, let me think of one, because that equation isn't an absolute, I guess. So if it does, because you remember, yeah, you're right, because we had if it's greater than or less than, the 2n minus m, I don't know, I'm blanking on the equation on top of my head, but the if there is a situation where if they're equal, it's determinate. If there's less than, I think it's not indeterminate, it's non-constrained. So you won't have, so yeah, the difference between being constrained, unconstrained, determinate, indeterminate, it'll focus just on that. You won't have a constrained, unconstrained question. So it's kind of a long-winded answer. But yeah, you can use that, but I would just, it'll probably be pretty obvious if it's an indeterminate. I mean, we're not trying to trick you or anything. So, and because remember, this is a test that all the different instructors signed off on. So, and some of us cover other things, and in more detail than others. Anyway, does that answer your question?
Yeah, thank you.
Sure, no problem.
Professor?
Okay. Yeah, sure.
Can you give like a quick example of like what a question would look like for determinate or indeterminate?
Oh, that's what I was talking about right here.
So you'll simply just give us like a diagram of the free body diagram, and you just ask us whether or not it's determinate.
That's correct.
That's it. Okay.
That's all it is. Yeah. And with the information that you have, can you calculate it? So, so you want to be able to identify the number that you have, the enough equations to solve a problem. So it's not just specifically with trusses. It could be with a machine or a frame. And so, so for example, if you had, let's see, what's a good example on this? Because this one I did over here, you could hypothetically have the four unknowns. I don't think if this one had it, it wouldn't be solvable. I think, so the best way to tell is remember what I said and it would either be a truss or it'd be a frame or a machine. That's pretty much what we'd focus on. But remember what I had said, that when you're solving for a frame, you either sum the moments of the entire object and then find the reactions, or you take it apart, usually sum them. So if you find that by summing the moments, you still have unknowns here, like say, for example, both of these were connected. Like this, if both of these had this and this, this and this, and then let's say you had a force applied here of 50 newtons, then, I know it's getting ugly, but then this would make it indeterminate in terms of being able to solve for these reactions. You just couldn't do it. But in some cases, you can have this, but it can still be solved. And so what your question would then be is if you take it apart like this in each of the components, can you solve? So if you end up with a component that has too many knowns to solve, then that's it. I mean, don't obsess over it. It's a small part. It might be one question. So, I mean, it's mainly, it's just to see how you think. So it'd be I think it'd be a pretty low level question. Okay, any other questions on part one? Okay, well, we can come back if you think of something. So
there's a question in the chat about the pacing and like how similar it's going to be to the midterm.
Oh, it's probably not going to be similar to, well, I mean, what do you mean by similar, I guess is my question, because this test was written by 7 different instructors. So it'll probably be quite different than the part A than what you guys did. It'll be like I said, multiple choice true false is what you'll cover in part 1. In part 2, which I'm getting to, that will probably look more like the midterm.
Do you have any idea about how many questions would be?
So part 1, I think part 1 will probably be limited to less than 20 questions, which sounds, that's about 3 minutes a question, but some of them will be really quick. Some will be a little longer. They'll tend to be about 2 points each, at 1, 2, 3 points each. So there won't be any really long part 1. There won't be any really long questions for you to answer. So all the calculations you'll do will be very simple calculations. They won't be, for example, if we were to give you a truss, we might just ask, we might give you part of the truss's reactions, or I'm sorry, some of the members' forces, and then ask you to find one. So then you just have to look at that particular joint per se. You wouldn't have to do the whole truss. So the idea is that we recognize that, an hour is not a lot of time. And so it's mainly just for you to apply, what you've learned about your understanding of the methods. That's our emphasis.
Are we still expected to show our work, or since it's multiple choice, we can just?
No, there won't be any avenue to show your work because the way it'll be auto graded too. So that's the other downside, is that there's no partial credit on it. So
all right,
go ahead and put in your answers, and then it'll spit them out to me. So no, you don't have to.
Thank you.
But go ahead.
How will the pacing of the final compare to the midterm?
I think it'll be a little less intense. I think the midterm was pretty intense. I think that, but you guys did surprisingly well. I mean, the average on part 1 was low, but the average on part 2 is actually pretty good. And so when I do my curve at the end of the quarter, I'll be pushing that part 1 up for everybody. But the second part, the average was in the mid 70s, so it's actually not bad. But yeah, I think you'll find you have a little more time. But it's going to be, I mean, we went back and forth with this when we were developing the test, and we've actually pared it down. And you'll probably still think it has a lot in it, but we've been paring it down because we're trying to keep it manageable within the time period that you have. But but the thing is, you're not going to have time to be, you can't read the question and then go look in the book for it and try to solve it. You won't have time to do that. So you really have to have an understanding. I mean, if you want to write out a cheat sheet where you put your thoughts for each chapter that are important, that would be a good thing to have. Then you can quickly reference it, because you'll know right away if it's asking you like, which direction will this moment go? You know, you may either intuitively know it, or you can, you know, quickly look at it and understand it. Or, you know, a question could be something like, if you're taking a moment about a line, you know, what would be an acceptable R value, R vector? And then so you might say going from, you know, A to B or B to C or C to D. And so you have to be able to recognize that when you're taking a moment about a line, you go from any point on the line to any point on the force. Okay, so now part two, there will be, it's kind of, it's a model a little bit after our final. Now, in the past, our final would be 4 to 6 questions, one from each category, and you'd have 3 hours. So in part two, what you'll have is you'll have 2 questions that I consider longer questions. These would be like kind of like the midterm questions that you had. So there'll be 2 questions, and they'll come from these categories. You'll have a moment of inertia, centroid type question. You may have a truss. So, and then that truss could be method of joints or method of sections. And that might include a zero force member. And then you may have a moment. So like force couple, or moment about a line, something like that. There might be a frame or machine. Those are pretty comparable in solving. There could be a 3D equilibrium. So, and I would say if there's a question like that, it'd be on par with like the midterm. So, for example, we did that 3D equilibrium with the window. If I were to give you something like that, it'd be pretty comparable to that. If the frame or machine question, that would be probably similar to something you had in the homework. It might be a little more, take a few more steps in order to find everything, or you may need to find, you know, more than just one member of it. So let's see, that's that. Oh yeah, and then our beloved friction. So there might be a question about friction, like how much, you know, what force is required to move this block up the hill, or, you know, you might have something connected to it, or so something along those lines. So there'll be 2 like that, and then there'll be a few more questions. The number isn't set yet, but there'll be maybe, we'll say 3 to 6 questions, which would be short calculations, where you get to show your work. There also might be, which is I think an emphasis, is where you draw FBDs. So I can tell you for sure there are going to be drawing FBDs on it. So make sure you can do that. That's going to be very important, because in this case, you're going to be submitting it. So I'm going to be grading it specifically on how well you drew. And I'm going to be grading, in the past, we would split up the exams and we would grade maybe one problem for all the sections. But in this test, I'm going to be grading everything. So I think that's better. But so what I mean by that, though, for example, is there was that one on the last exam that you probably have looked at, but maybe, or maybe not, the solution. And I realized that one was kind of a tough problem on the last exam, but it had something look like this. And then it had,
Can't see.
yeah, I'm going to move it. Just give me a sec. So these are connected. And then let's see. Let's say that. So let's say that's connected there. We'll say this is connected over on the wall. Let's say we could have, force going that way. And of course, it'll be a much better drawing. But the point is that along the wall, this could be a ball and socket joint. All right, connecting that. So, and then this could be another ball and socket over here. And maybe you might, or you could even have something along the lines where you have a journal bearing. And so, and then maybe it curves over here and then you have another journal bearing. And so the idea again is to recognize, what kind of reactions do these have? Now, remember, whenever it says cannot support an axial load, that's this direction. Or in this case, it'd be that direction for that one. So this one's going to support force there and there, but not there. These are going to have one there and there, but not in this direction. Now, the other thing is if you have something, and this is something we really didn't do a lot of, but if you have something where you have let's say like a telephone pole or something that's mounted on the ground, right? Now, if you have something that's mounted on the ground in 3 directions and I draw the axes for it, then.
Can you move it down, please?
Yeah. So if I draw the axes for this, so here's that, and so there's that, and then let's just pretend like it goes up like this. Actually, let me do this. Let me redraw it. I'll just redraw it. So. And so we have this, and let's say, you have tension, tension, tension. And so you're asked to draw the free body diagram for this pole. Now, so far, when I've shown you something like that, it usually had this end look something like this, where it would have a ball and socket, right? So that meant it had force in all directions, but it didn't have moments. This one would. So if you're drawing the free body diagram for this, if it's mounted, you have to remember that you have moment, mx. So if this was A, we'd say MA, the X, and then we'd have MAZ, and then MAY. In addition to the AX, AZ, and AY. And you can see how it can get kind of messy. That's why we don't usually bother with dimensions on free body diagrams. All right. And then, of course, you're going to label this tension, whatever these points are, that tension and that one tension. My point is that this is an ugly drawing, but it's just you want to make sure that you understand these reactions and how to draw on all these. And so this is something that would be in part 1, but that might be extended in part 2, where you've seen, free body diagrams and you've identified them, but now you actually have to go and draw them yourself. That's be really important. So please practice that, because there'll be, I would say, probably 25% of the exam, if not more, will have points that you could lose if you do not draw good or recognize good free body diagrams. And this is going to be really important when you guys go to dynamics. Okay, let's see. So for me, on these longer problems in part 2, and pretty much anything in part 2, the clearer you can make it for me, the better. I know you'll have an hour and a half for this part, so you should have enough time. You should have, I would say, 25 minutes to spend on each of these longer problems, and then the balance of your time will be on the shorter answer problems. But one of the things that, so for example, if this was, say, the problem and you were trying to find, I asked you to find, the reactions at a and the tensions, which you couldn't do with what we know because there's way too many unknowns here. But reactions A and tensions, then, I mean, you probably could, but it'd be more than you'd want to. Anyway, what I would want to see, the most important part of this setup would be where you show me the sum of the moment about A to 0, and then you did your R cross F plus R cross F and so forth. So this governing equation that you set up and then you subsequently set it up with the appropriate numbers, that's more important to me than the fact that you got all the math right and spit out an answer at the end.
I have a
So
question.
yes.
Are we going to be allowed to use like calculators for like finding these moments?
Oh yeah, of course. Yeah. Yeah. I mean,
Cross products.
yeah, you don't have to. I mean, if you set everything up and then just give me an answer, that's fine. I don't expect you to show me by hand how you did the cross product.
Got it. Thank you.
Yeah. So let's see. Trying to think what else is there.
I had a question.
Sure.
So for the midterm, you posted like a study guide and then a bunch of like old midterms. Are you gonna do that for the final at all? Like post like old finals that we could use to study or something?
Well, two answers. This is a totally different final than what we've ever done before. So there's nothing I can post from the past. And the other thing is that the department, even if I could, the department doesn't want us posting past finals. I apologize, but yeah, it's kind of no secret what the format is. I would say there's probably nothing that you can garner from the past for part one, because again, it is brand new. Part two, the best advice I would give you is look at the problems I gave on past midterms, because in past midterms, well, actually I only went up to chapter 4, so that would help you. I would say if you look at some of the harder homework problems, those are probably on par with what you would see. So, I'm not trying to hand wave or give you a non-answer, but there's really nothing like examples I can give you. I would just say is that you want to be sure that I guess one way to say it is that we want you guys to do well, and we're not going to give you a question on the final that, because how there's some of those problems in the homework where they require like a certain trick or there's some thing about them. And this is really much more evident when you take dynamics, but these are going to be kind of middle of the road, mainstream types of questions that just test your fundamental knowledge. They're not going to require you to dig into your past and find some weird math trick that you never heard of or had forgotten. So I would just say is that, be sure, like if you're doing moment of inertia centroid, you'll probably be given some kind of a composite shape. And so, past shapes have looked, you might have something that looks like this, and then maybe it's missing this corner. So it looks, maybe something like that. And then maybe what we would do is we'd say here and here, we'd say, there's your X and the Y. And we'd say, okay, now find the centroid about the Y axis and about the X axis. Or we could give you the centroid and then, maybe the centroid's right here, and say, find the moment of inertia about that. And so, of course, that you're going to use the parallaxis theorem to find the moment of inertia of this empty space, moment of inertia of this triangle, and then the moment of inertia of the entire square, and so forth. So the problems that we'll give you will be pretty much similar to in the way you approach them to what we've seen before. So a truss would be nothing more complicated than the basic triangle trusses. There won't be any weird geometry in the trusses. If we give you a truss, it's probably going to be something, it just looks like a garden variety square. There won't be, like, I know there's one in that homework that had that really kind of weird, look kind of like that. Is it a weird angle, but you won't have anything like that. Same with frames or machines, should be pretty straightforward. 3D equilibrium, I would say if you look back, if you can do the one from the midterm, then you'll be fine. If we give you one like this, it'd be pretty much the same procedure. So friction is kind of the only real unknown because we haven't really, I gave you a quiz question on that, and most of you did fine on that. But as far as the specific types of questions, friction has probably the most abundance of different types of questions that you could give. So most likely if we give you something, it'll probably be something simple, like say, if you had, let's say you had a block, another block here, kind of like I did an example like this and so maybe you're going to apply a force P here, and then you're going to have to determine, what amount of force P is required to push this up the hill. And so again, you're going to treat each of these individually, a free body diagram for this. Once you know your free body diagram, figure out how much force it was required to push this, and then you can transmit that to there, and then you just basically figure out how much force is going to push this one, knowing that gravity is going to take it down. So there's lots of permutations you could do with this. But that's it. Again, no wedges, no belt friction. So you have once you do this part, you have 90 minutes and then a 5-minute grace period to turn it in. So please don't work until it's 94 minutes and then try to send it to me. It's really important that you turn this in and get it. Okay. So we will on test day, we'll start this right at 7:10, and then it'll go from 7:10 to 8:40, and that'll be that.
Do we need to be in a Zoom room for that, or is that just like on our own, but at that time?
No, that'll be synchronous. It'll be everyone will be in the Zoom room. I'll be present, and the main reason for that is that if while taking the test you have questions, you can talk to me right away. So, I mean, if you want to have your camera off and muted, that's fine. I don't need to have everyone's face there. I'm not going to stare through it. I'm honestly, I'm not worried about cheating. I mean, there's always ways you guys can figure out if you're really hell bent to do it. But the reality is the amount of time you have and the amount of work, you're just going to need to focus on the work. You're not going to have time to go call the internet for answers. It's just not going to happen. So, and I don't think you'll need to. If you've kept up with the material this far, you should be fine. I sat down and took the test, and I thought it was, it's challenging, but it wasn't something that's, going to kill you guys. And again, if there is a bad question in there and people don't do well, then I throw it out. Simple as that. So that's my, I want to make sure everyone gets through this class but they understand it before they move on. So you guys probably have the best assessment of how well you understand the material.
I have a question.
Sure.
Are both parts of the test open note or just the first part?
No, both are. Yeah. So you're free. So there's a pledge. That's something that the department wanted to do, is at the beginning of each, you'll put your initials, you'll sign your name, just a pledge saying that you won't cheat. And I think one of the things in there, it says you won't use any, online resources. So I guess the idea is that we don't want you searching Chegg to find it. Although these are like our own questions. So I don't think you'd find them in Chegg no matter how long you spent. But the main thing is we don't want you, having someone else online that you're talking with at the time. Some instructors set it up and they have everyone have cameras and they're muted, or they're not even muted, they're unmuted, and you could sit there and hear every sneeze and sniffle and the whole time. But I don't want to put that pressure on you. I don't want you to think that there's this eyeball staring at you the whole time. So I'd rather you just focus on taking the test. Okay. So any general questions about the test? Any specifics about anything? Okay. Well, what I would suggest, go ahead.
I was just wondering if you have like a formal document that has all of the lists of topics, or was that laid out in the lecture here?
Yeah, that's what I was doing here when
Okay.
I was closed down.
Okay.
So Yeah, I did record it though, so if you missed something, you can play it back.
Yeah.
But so I'd just say, spend some time studying. I know you guys have other classes, other fish to fry, but have some time. Hopefully, enjoy your break, and then we'll do this again on Saturday. Next Saturday, I'll send out a reminder for it, and I figured instead of having it Sunday the night before, I give Saturday. That way, if there's anything that you come across that you don't know. Now, the one we'll do on Saturday will just be a question and answer session, so I won't have anything formal to present. I'll just basically answer questions, and I will have office hours tomorrow, my normal time. So any other questions for you guys? All right.
I had a real quick question.
Oh yeah, sure.
Yeah, it's about the class. It's when are grades going to be updated for the last 2 quizzes that we took?
As soon as I can. Are you trying to figure out credit, no credit?
Yeah. Well, I'm pretty sure I'm gonna take it for grade.
Yeah. I'm gonna try to get those up and posted by tomorrow because I know that there's some of you on the credit, no credit fence. So yeah, I am working. I think there's I don't post the quiz until I've graded everyone. So even though it looks like it's not done, a lot of them are done. I just have it until I get everyone's done, then I just post all at once. So I think there's a homework assignment and 2 quizzes I owe you guys still. So yeah, I'll try to get that up as soon as possible. Okay.
Thank you.
All right, no problem. Oh, and
Does
one.
anyone?
Oh, go ahead.
I was just wondering. Does anyone know the last day to decide the credit or no credit?
It's
I
tomorrow.
think it's tomorrow.
Oh, okay.
Right. Yeah. So, sorry, I was just thinking of something. Oh yeah, if you guys can, please fill out the evaluations for the class too. That helps me out. So it's only open till tomorrow at midnight. So same time as credit, no credit. All right. Okay, well, if there's no other questions, I'll call the night. And if you have questions, shoot me an email. Otherwise, I'll see you guys next Saturday or office hour tomorrow, but most likely next Saturday for the final review. All right.
All right, thank you.
Okay,
Thank
thank you
you.
guys. Have a good break.
You too.
Thank you. Bye-bye.